students, now let us move on to another part of the syllabus. It is numerical differentiation using Newton's backward difference method. Okay, so as you know that already we have done Newton's forward difference method. So we are again going to repeat similar type of derivation, but with a from the backward way. So I will tell you what does it mean when we say it is a backward method. So in the same way we will let us consider a data set. Let us consider a data set and it is represented as, okay, so this can also be written as x y y I. So yi is nothing but the function, okay, at x. And it is again for equi-spaced data. Okay, so what is the form of the data? Xi, it goes like this, ih. Okay, and where h is the step length, as we have discussed already. Okay, now Newton's backward difference formula. Okay, so we will use the Newton's backward difference formula, and we will proceed as we have done for the first part for forward difference method formula. So here we have fx is usually given by fxn plus x minus xn. Let me write it full, then I will tell you in detail what is the difference. And factorial to h square del to fxn plus, it will come, and we are writing the n term, 1 n, then we have del n fxn. So that would be our equation number 1. So you can see that here we have started with xn. In forward difference method we had x naught in this place, and here now we have xn. Here we have, in forward difference method we had x minus x naught. Here we have x minus xn. See, whenever we start a data, it goes like this: x1, x2, x3, and it goes up to xn. So when it is a forward difference method, so we start from go like this. This is forward. Okay, so our first term is x naught, then x1, then x2, then x3. But when it is a backward difference method, we have the same set of data, but we start from the last term. So this is called backward difference method. So for us, we will start with xn, then we will start with xn minus 1, then we will start with xn minus 2. So literally, if you want to say, here x naught will be the last term, here xn is the last term. So this is a concept of this method. So how it is practically used, I will get to know throughout the process. Now let us assume that x is a point, okay, which is very close to the point xn. Okay, so if I want to take x minus xn, it is going to be a very small m quantity. Okay, so difference between them will be very small. So let it be given by sh. Okay, so h is a step length and s is a constant. So x minus xn is equal to sh. If you remember, in forward difference method we had x equal to x naught plus sh. So it was like x minus x naught equal to sh. So here we have, since x naught is replaced by the last term, so it is nth, so xn. So you can draw analogy between these two things. So in our case we have x minus, earlier we had x minus x naught equal to sh. Now we have x minus xn equal to sh. Now we will use this in equation number 1. So using this in equation 1 we have, okay, so what do we have? So simply we had fx, isn't it? So fx is nothing but, now since x is equal to xn, since x is equal to, sorry, x minus xn equal to sh, so x will be equal to sh plus xn. So xn plus sh, so it is simply, so it will become equal to, so we had fxn. If you look at the first equation number 1, let us go back to this. So fxn, then we have x minus xn. X minus xn is nothing but sh, isn't it? So we can simply write sh. Then we had factorial 1 h, then fxn. Then we had x minus xn, so it is sh. Then we had x minus xn minus 1. And then it was factorial to h square del 2 fxn. And then so many terms will be there. And then we had x minus xn means sh, then x minus xn minus 1, then it will go up to x minus x1, then factorial n h to power n del n fxn. Now we need to do some modification. So here you can see we don't know this term, we don't know this term, they don't know this term. So for that we need to do some modification. I will do some rough work. I will show you how to do that. So suppose that if you want to write x minus xn minus 1. So x is nothing but xn plus sh. X is nothing but xn plus sh. From here x is equal to xn plus sh minus xn minus 1. sh I am writing. Now these two terms are consecutive terms. So difference between them is nothing but the step length. So it is equal to h. So s plus 1 into s. So that is a, so here in place of x minus x1 I can write s plus 1 into h. So here I can write s plus 1 into h. Okay. Similarly we have here in this term x minus x1. So x minus x1, xn plus sh x1. So sh so gap between them will definitely equal to n minus 1. and it will be equal to h. So s plus n minus 1 into h. So it is nothing but s plus n minus 1 into h. So in this case, here we have 1h, here we have 1h, here we have, so in this way we will have nh's. So here also we have nh, so they will get cancelled. So final form will be like this: fx is equal to fxn plus s into del fxn plus s into s plus 1 by factorial 2 del 2 fxn plus s into s plus 1 s plus 2 s plus 1 s plus 2 s plus n minus 1 divided by factorial n. So that is equation number 2. Okay. Now differentiating 2. So dfx dx. So as usual, it can be written as, so ds dx already we have discussed in earlier video, it is equal to 1 by h. So df ds, so this is nothing but f dash x. So f dash x is simply is equal to 1 by h. Now I am not going to repeat all this thing, we have already done it in the first video. So you will look into that and you will solve it according to your convenience, and you will check whether the results are correct or not. So the first term goes like this: it is fxn plus s del fxn plus s into s plus 1, then just factorial 2 del 2 fxn s into s plus 1 s plus 2 factorial 3 del 3 fxn. Remember, these values are constant values. This is a constant value, this is a constant, so they will stay always out of the differentiation. Then we have so many terms, and then it goes like this. So I am just repeating. Factorial n. Now you need to differentiate this whole thing with respect to s. So what remains, it will give you 1 by h del fxn plus 1 by 2 twice s plus 1 del 2 fxn plus 1 by 6 3s square plus 6s plus 2 del 3 fxn plus 1 by 24 4s cube plus 18s square plus 22s plus 6 del 4 fxn plus 120 5s to power 4 plus 40s cube plus 105s square plus 100s plus 24. Then it goes del 5 fxn. So that is our equation number 3. So this equation number 3 also you need to remember.